Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड इयर सिलेबस कंप्लीट कर सारी एबे मु प्लस थ्री CBCS फिजिक्स ऑनर्स जीई आ MSc फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक कर देबा और चैनल को सब्सक्राइब कर देबो यू कैन शेयर इट विथ योर फ्रेंड्स आल्सो इट्स कंप्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन पई बेल आइकन को एठी ऑल रे सेट कर देबो तापरे वीडियोज रो क्लैरिटी बढ़ावा पई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें नॉन इनर्शियल एंड रोटेटिंग फ्रेम्स आता सहित कोरियोलिस फोर्स ए विषय पढ़ा सो फास्ट देखा व्हाट इज ए नॉन इनर्शियल फ्रेम ऑफ रेफरेंस देख इनर्शियल फ्रेम कहले आम बुझा जो फ्रेम रे न्यूटन्स लॉज ऑफ मोशन वैलिड रही था ओके सो दीज इनर्शियल फ्रेम्स आर एक्चुअली अनएक्सिलरेटेड ओके that means they are moving with a uniform velocity but whenever we are considering the accelerated frames then it will be called as the non-inertial frames because in such a frame the velocity is not uniform okay and the force free particle will seem to have accelerated right and if we do not consider the acceleration of the frame by applying the Newton's law of motion of the force free particle then it will appear that a force is acting on it okay so जेहेतु एक्सेलरेशन आसिला तो निहाती भाव में से पार्टिकल रो मास सहित सेटा अटैच हेबो एंड द प्रोडक्ट विल गिव राइज टू अ फोर्स ओके सो दिस मीन्स दैट in the accelerated frames Newton's law of inertia is not valid and thus a non-inertial frame of reference is defined as a frame of reference in which the Newton's first law does not hold true and observer in this rotating frame generally non-inertial frame कहले हमें rotating frame को बुझिबा will see a force on a force free particle and hence all rotating frames are also non-inertial okay अच्छा आकु बढ़िबा एबे देखिबा व्हाट इज अ फिक्टिशियस और स्यूडो फोर्स तमे देखिथिबो प्रत्येक जो फिल्म किंबा सीरियल रो स्टार्टिंग रे गोटे पारा लेखा ही था all characters in this film are completely fiction बा एई कहानी रो सबु चरित्र गुडाक काल्पनिक अटे ओके जनरली ए बडे लिखा था सो फिक्शन कहले हमें काल्पनिक जिनस को बुझिबा सो फिक्टिशियस और स्यूडो फोर्स इट इज एक्चुअली एन इमेजिनरी फोर्स कहि पारो ओके सो याकू बुझिबा पय हेले लेट अस कंसीडर टू फ्रेम्स गोटे हला एस आ गोटे हला मूविंग फ्रेम दैट इज एस dash which is now moving with an acceleration you can see that is a0 okay so एटी एक्सिलरेशन जदि a0 हला that means velocity uniform नुह because जदि velocity uniform ताले it is constant and its acceleration will be 0 so here s dash is moving with an acceleration that is a0 with respect to the rest frame that is s okay now we consider a particle at the position p okay now on this particle no external force is acting and will be 0 if we consider from the rest frame that is s किंतु जदि आम मूविंग फ्रेम s dash रू consider करिबा we observe then we will find out that there will be an acceleration minus a0 is acting on this particle that is p okay so in the frame s dash the observed force on the particle is minus ma0 right and here we have taken m to be the mass of the particle so एबे हमें आसीगला definition part को such a force which does not really act on the particle but appears due to the acceleration of the frame is called as the fictitious or pseudo force okay So here in this case the fictitious force on the particle P will be how much? That is F0 equal to minus ma0, and here the accelerated frame S dash will be the non-inertial one. Okay, now if we consider a force Fi which is applied on the particle and Ai is the observed acceleration in the frame, that is rest frame S, then as per the Newton's law Fi is m into Ai. Suppose the frame S dash এটা coincide করଥିଲା at the initial time, that is t equal to 0 with the rest frame S, then at that time coincide କରିଛି, but ଆମେ at any instant of time ଯେତେବେଳେ t ଆକୁ proceed କରୁଛି, okay, the position vectors of the particle ଏବେ ଦୁଇଟା frame ରୁ ଅଲଗା ଅଲଗା ହେବ. Okay, you can see ଏଠି ଆସୁଛି ri, ଏଠି ଆସିଗଲା rn. Okay, so দুইটা position vector ଆମେ ପାଉଛୁ, right? That means we can connect these two position vector by applying the laws of motion. Ri is equal to Rn plus half a0 t square. এটি a0 হয়ে গেল acceleration of the frame s dash with respect to the rest frame s. So ଏବେ ଯଦି double differentiation କରିବା এই equation କୁ with respect to time, then it will give d square ri by dt square equal to d square rn by dt square plus a0. Now it is d square ri by dt square is nothing but the acceleration ai in the frame. So d square rn by dt square yaku bhi acceleration hame likhi pariba, that is an. That means we have now the equation for the acceleration ai equal to an plus a0 or ai minus a0 equal to an. দুই সাইড রে মাস যদি আমি মাল্টিপ্লাই করে দিলে we will get the force. Okay, so if we define the force on the particle in the accelerated system as per the Newton's second law, according to which force is the product of mass and acceleration, তাহলে Fn will be equal to Fi plus F0. So এটি Fi হয়েগলা real force which is acting on the particle and F0 হয়েগলা fictitious force. Okay, thus the observer in the accelerated frame will measure the resultant, that is the total force, which will be the sum of these two, that is the real and the fictitious one. So total force equal true force by real force plus the fictitious or pseudo force. Okay, so yaku ଆଉ ଗୋଟେ example ଆମେ ବୁଝି ପାରିବା. Suppose ଗୋଟେ box ନେଲା which is falling in the gravitational field of earth with an acceleration that is a0, which is minus g n cap. Okay, minus g ଏଥିପାଇଁ because downward fall ହେଉଛି. So ଏଠି g ହେଇଗଲା acceleration due to gravity, n cap ହେଇଗଲା unit vector जोटा कि तार direction को assign करूची, which is in the upward direction. मने रखो n cap टा होची upward direction आडकू ହେଲା, because एटा acceleration रो direction को assign करूची आ acceleration due to gravity होची downward, तेणु करी एठी minus symbol लागिला. Now if we consider a particle falling freely inside the box, then the fictitious force on the particle will be how much? F0 equal to minus ma0, that is mg n cap. So as the real force on the particle due to the acceleration of the earth is minus mg n cap, then total force যদি ଆମେ ଏବେ ଦେଖିବା observe କରିବା by the observer inside the box, then Fn equal to Fi plus F0. So ଏଠି ଦେଖ plus minus cancel ହେଇକି 0 ହେଇଗଲା. That means ତମେ ଯଦି ଗୋଟେ box ରେ ଅଛ, or simply you imagine yourself to be inside a lift, ଗୋଟେ lift ଭିତରେ ଅଛ ହେଲା, ଗୋଟେ ମଣିଷ ଗୋଟେ lift ଭିତରେ ଅଛି, ଅକସ୍ମାତ lift ଉପରୁ ତାର ତାରଟା ଛିଣ୍ଡିଗଲା, lift will fall freely under the action of gravity. Now the person inside this lift will feel weightlessness. Okay, ତା ଉପରେ କିଛି ବି ଆଉ ବଳ କାର୍ଯ୍ୟକାରୀ ହେବନି because ଏଠି total force ଟା 0 ହେଇଯାଉଛି, right? So if the particle has no initial velocity relative to the box, then it will seem to remain suspended in the mid-air at the same place inside the box. Okay, now suppose that the box is moved with an acceleration. Okay, ଏବେ ଯଦି ଗୋଟେ acceleration ରେ move କରୁଛି box ଟା, that is g and cap in the upward direction now relative to the ground, then in such a case the real force Fi and the fictitious force will be in the same direction. So Fi F0 accordingly ame paigala tale ebe total force jodi kadiba it will be 2 times, okay, minus 2 mg n cap. Okay, so this means that the observer which is stationed in the box having an acceleration g in the upward direction will measure a force that is 2 mg which is downward on the particle. Okay, so ଯେମିତି କହୁଥିଲି ଏଥିପାଇଁ ଗୋଟେ ଲିଫ୍ଟର ଆମେ ଏକ୍ଜାମ୍ପଲ୍ ନେଇପାରିବା which is moving relative to the ground. Okay, ଆଉ ଏଠି ଆମେ ଦେଇଦେଲା ଫାର୍ଷ୍ଟ ପଏଣ୍ଟରେ with constant velocity upward or downward. Second consider କରିବା with an acceleration that is upward. ତାପରେ ଥାର୍ଡ଼ରେ consider କରିବା with an acceleration minus a0 that is in the downward direction. Okay, we can see in the figure. देखो फर्स्ट फिगर रे एटा गोटे पर्सन लिफ्ट रे अछि कांस्टेंट वेलोसिटी सो एक्सेलरेशन हे गला 0 एठी एक्सेलरेशन होची अपवर्ड डायरेक्शन रे आ एठी एक्सेलरेशन हला डाउनवर्ड डायरेक्शन रे. ओके, now let us say that this person is having a mass small m and we try to calculate his weight. Okay, so first हमें जो consider करूछु फ्रेम बा लिफ्ट एटा यूनिफॉर्म वेलोसिटी रे मूव करूची सो एक्सेलरेशन हे गला 0 and here we assume that the earth is stationary and a frame is fixed with the earth and it is the inertial frame. Okay, so in all the cases the force in the inertial frame ए तीनटा जाको केस पाई real force जदि हमें कहबा it will be how much Fi. Okay, I for inertial it is minus mg n cap, right? So ଏବେ ଫାର୍ଷ୍ଟ କେସ୍ ଯେମିତି କହୁଥିଲି ହିୟର ଦ ଅବଜର୍ଭର ଏଠି ଯେଉଁ ପର୍ସନଟା ଅଛି ଆମେ ୟାକୁ ତଳକୁ ମୁଭ୍ କରୁ କିମ୍ବା ଉପରକୁ ମୁଭ୍ କରୁ ଯେହେତୁ କନଷ୍ଟାଣ୍ଟ ଭେଲୋସିଟିରେ ଏଇଟା ମୁଭ୍ କରୁଛି ସୋ ଏକ୍ସିଲାରେସନ୍ ହେଇଗଲା 0, ରାଇଟ୍? ସୋ as the acceleration is 0 with respect to ground, thus the frame of the lift is inertial and in both the frames the force on the man will be same. Okay, that is Fi equal to minus mg n cap. ଆଉ କିଛି ବି ଏଠି fictitious force ଆସିବ ନାହିଁ. ମନେ ରଖ fictitious force ସେତେବେଳେ ଆସେ whenever we are considering accelerated frames. ଏବେ second example को आसीबा. Okay, second example रे here we have some acceleration in the upward direction. ତେଣୁ କରି ଏବେ ଏଇ केस रे तमरो force total force जदि हमें calculate करिबा it will be Fn equal to real plus the fictitious. Okay, so it आसी गला total force. आ थर्ड केस रे acceleration downward थिला so total force गला again real for plus fictitious, now this much. Okay, thus we say that when the lift is accelerated upward then the weight of the man is mg plus a0 माने weight increase होउची and he becomes heavier. Okay, while the lift is accelerating downward it is losing its weight because mg minus a0 होउची. Okay, and जदि lift टा freely fall कला, okay, if the lift falls freely ताले a0 equal to g ହେଇଯିବ and the weight of the man becomes 0 because एठी g minus g ହେଇगला 0 and he feels weightlessness जेमति मु स्टार्टिंग रे कहउथली. Okay, now let us see what is centrifugal force. एटा प्लस 2 रे भी तमा पढिथिबो. It is a force which is acting along the radius and away from the center in case of circular rotatory motion. Okay, so here we consider a particle having mass small m, okay, on the circumference of a circle. Okay, a circle ro circumference रे ए particle टा अछि. एठी हमें radius नहीं गला small r and we take the angular velocity to be equal to omega. Okay, एठी omega angular velocity रे एटा move करूची. Now for example consider a stone which is attached to one end of a string. Then in an inertial frame the centripetal force acting on the mass m एटा ହେଇଯିବ real force that is Fi equal to minus m omega square r. Okay, and here R is directed outward from the center. And in case of rotating string with stone, the centripetal force is provided by the tension. Okay, এটা আমি জানিছু, so the real force will be equal to the tension. Okay, now suppose that a frame is rotating with an angular velocity omega relative to the inertial frame, so that in the rotating frame the mass is at rest. Okay, now in this non-inertial frame, that is the rotating frame, the observed acceleration an of the mass m will be how much? 0. Okay, so ଏଠି an को ଆମେ ନେଇଗଲା 0 and consequently total force ଏବେ ଆସିଗଲା simply product of mass and acceleration, which is also 0. Now we know that total force is the sum of the real and fictitious force. याकू पुट करिबा ताले fictitious force रो value आसीगला m omega square r. Okay, so this fictitious force is directed now away from the center, again along the radius, and याकू आमे कहिबा centrifugal force. Okay, so in the rotating non-inertial frame, the acceleration जदि आमे नेगला an, our total force is Fn on the mass m, then it is 0, and Fi real force is equal to tension for the stone string arrangement. Okay, so here we have tension plus the fictitious force equal to 0. That means in the non-inertial frame, the centrifugal force is balanced by the inward tension in the string, and in general, in the case of rotating frame, the centrifugal force is equal to and opposite to the actual force, and both are acting on the same particle. So remember here the centrifugal force is a pseudo force, eta bi gote pseudo by imaginary by fictitious force, and it appears in the rotating frame due to the rotation, and it is not to be confused with the reactionary force which is acting on the center away from it, that is on the hand in the stone string arrangement. Okay, सेटा stone टा तमरो हाथ आड़ को टाणी होनी, rather if we consider at any point जदि गोटे string सहित you are tying a stone, at any point जदि string break करिगला, the stone will fly along the tangent, right? Okay, याकू example रे भी देखो एठी गोटे problem solve करिकी भी बुझाइछि, you can read it out. Next we go forward. Uniformly rotating frame. Okay, so we know that earth itself এটা rotate করছে about its axis, and it is taking time around 24 hours. Okay, although it's not exact. Therefore any frame which is fixed in the earth will also rotate with the earth, and it will be a non-inertial frame. Okay, so एथिपाई आमे consider करिबा गोटे frame as you can see in the figure. Okay, here we are taking two frames, गोटे हला s आ गोटे हला s dash. Okay, having coordinates respectively xi yi zi and xr yr zr, coordinates by axis कहि पारो. Okay, आ एठी angular velocity आमे नै गला this one which is omega. Okay, so एठी s dash move करूची बा rotate करूची with an angular velocity omega relative to the inertial frame, that is s. Okay, and this rotation is about this origin, that is the center, common origin eta o. Okay, आ एठी z axis सहित आमे नै जाउछु direction of your rotation. Okay, that means s dash is rotating about the z axis, so zi equal to zr एठी हेइ जाउछि. Okay, अच्छा, now in case of your earth, जदि आमे earth कथा एठी consider करिबा, एठी common origin जो अछि o may be considered as the center of earth. Okay, एको आमे earth रो center नै जिबा, आउ z axis which is coinciding with the rotational axis of the frame s dash as the rotating earth relative to the non-rotating frame, that is s. Okay, अच्छा, जे कोनसी गुटे एबे particle को नो आमे p, जदि यार पोजिशन बा रेडियस वेक्टर आम बाहर करवा वी विल जॉइन P and O. Okay, this will give you the radius vector, and in both the frames the position vector will be having the same magnitude, that is Ri equal to Rr equal to R. Okay, because origin is taken to be the same. Okay, so if the particle is stationary in the frame S, the observer in the rotating frame S dash will see that the particle is moving oppositely with a linear velocity, that is minus omega cross r. Minus kaiki because opposite direction रे move करुछि. Thus if the velocity of particle in the frame S is dr by dt, okay, I for initial, then its velocity will be in the rotating frame is dr by dt r plus r for rotating. Okay, ताले आमे पाइला इक्वेशन एटा रेट ऑफ चेंज ऑफ वेक्टर भी एई प्रकार इक्वेशन तमे पाइथिलो, किंतु सेई जगह रे एटा प्लस थिला. ओके, प्लस काहे की थिला बिकॉज आमे स्पेस जो हमरो जो इनर्शियल फ्रेम अछि बा स्पेस सेट ऑफ एक्सिस तार वेलोसिटी को आमे लेफ्ट साइड रे लिखुतलु. ताले देखो ए हिसाब रे आमे लिखुतलु ए इक्वेशन ही आमे पाउथला रेट ऑफ चेंज ऑफ वेक्टर रे dr by dt I equal to dr by dt r plus omega cross r. Okay, acha, now in fact this equation holds for all vectors and relates the time derivatives of a vector in both the frames S and S dash. Therefore the equation 12 may be written in form of operator. एबे कैपिटल R को आमे हटे दबा ताले ऑपरेटर इक्वेशन ए हिसाब रे आमे लिखि परिबा. एटी टिक्की प्रिंटिंग मिस्टेक अछि, ओमेगा क्रॉस हबो एटी R हबो नाही. ओके, I will edit it. So let us write dr by dt to be equal to v. V is velocity of the particle. ताले vi equal to vr plus omega cross r. Now we operate d by dt from both sides. Okay, so that dvi by dt of I equal to this much. अच्छा, एबे vi रो जो वैल्यूटा आमे इक्वेशन 14 रो पाइथिला ताकू सब्स्टिट्यूट करिबा. ओके, सब्स्टिट्यूट करिबा, that is dvi by dt. We put the value of vi here. Okay, vi रो वैल्यू ई जगह रे जो थिला याकू पुट करिबा. ओमेगा क्रॉस अगेन vi रो वैल्यू हमें पुट करला. We try to solve it further. Okay, ताले देखो एठी dv by dt को आमे नै गला एक्सीलरेशन, dr by dt हे गला तमरो वेलोसिटी. ताले in terms of acceleration we are getting this equation like this. Okay, अच्छा, further आमे जेहेतु यूनिफॉर्म एंगुलर वेलोसिटी नउथुला, so ओमेगा हे गला कांस्टेंट, that means d omega by dt equal to 0 हे जिवो. So acceleration हे गला एतिकी. Okay, d omega by dt रो टर्म टा कटि गला. अच्छा, जदि एबे हमें पार्टिकल रो मास नै गला स्मॉल m and we multiply small m both sides, ताले accordingly हमें फोर्स पाई जिबा. ओके, m a r हे गला तमरो रियल आउ फिक्टिशियस फोर्स रो समेशन. ओके, सो फिक्टिशियस फोर्स हे गला f0 केते हे जिवो ए जो क्वांटिटी टा अछि माइनस सहित इंक्लूड करिकि. ओके, दिस इज आवर फिक्टिशियस फोर्स f0. एठी -2m ओमेगा क्रॉस vr हे गला कोरियोलिस फोर्स आउ -m ओमेगा क्रॉस r हे गला सेंट्रीफ्यूगल force. Okay, दुईटा fictitious force आसुची. So centrifugal force is the only fictitious force which is acting on a particle which is at rest, that is Vr equal to 0 in the rotating frame, and centrifugal force may be written as equal to m omega square small r. It is small r हे गला गोटे vector from the axis of earth to the particle and normal to it. Okay, याको डेराइव मध्य हमें करि परिबा. नेक्स्ट वी कम टू द कोरियोलिस फोर्स. सेंट्रीफ्यूगल तो देखिला, एबे देखिबा कोरियोलिस फोर्स व्हिच इज फाउंड आउट टू बी -2m ओमेगा क्रॉस vr. एटा होची गोटे फिक्टिशियस फोर्स व्हिच एक्ट्स ऑन ए पार्टिकल केतेबेले ओनली व्हेन इट इज मूविंग विथ रेस्पेक्ट टू द रोटेटिंग फ्रेम. ओके, thus in the rotating frame, if a particle moves with a velocity that is vr, then it always experience a Coriolis force that is -2m omega cross vr, which is acting perpendicular to its path and opposite to the direction of the vector product, that is omega cross vr. एटा हमें जानिछु because a cross b जदि हमें क्रॉस प्रोडक्ट करूछु the result, suppose यार value होगा C, then C will be perpendicular to both A and B, right? Now due to the Coriolis force, a moving particle in the northern hemisphere is deflected towards the right of its path. এটা মনে রাখো. Similarly, in the southern hemisphere, it will be deflected towards the left of the path. Okay, so the effect of Coriolis force is appreciable when it acts horizontally, and in case of your horizontal component এটি রহিব Coriolis force ର, because in the vertical direction its effect is masked by the large gravitational force. Okay, gravitational force যেহেতু সেই vertical direction রে କାର୍ଯ୍ୟକାରୀ ହେଉଛି and it is huge as compared to the Coriolis force, ତେଣୁ ତାର effect ବେଶୀ କିଛି ରହିବ ନାହିଁ. କେତେବେଳେ ବେଶୀ appreciable effect ରହିବ ଯେତେବେଳେ horizontally ଏଟା କାର୍ଯ୍ୟକାରୀ ହେଉଛି. Okay, now since this force is a comparatively small force, so its effect is observable only when a particle travels a large horizontal distance. Okay, so when the velocity Vr of the moving particle in the rotating frame is horizontal, then the horizontal component of Coriolis force will be only due to the vertical component of omega sin phi. Okay, that is the angular velocity omega, where phi is the latitude. Okay, so এই angular velocity omega ର vertical component ହେଇଗଲା omega sin phi. Okay, phi ହେଇଗଲା latitude of the place. ସେଇ ଯୋଉ Coriolis force ତା ଉପରେ depend କରିବ. Okay, hence the magnitude of the horizontal Coriolis force will be 2m omega v sin phi, and it will be 0 for phi equal to 0, that is at the equator. We know that at the equator the latitude is 0. Okay, acha ଆଉ ଗୋଟେ important effect ଯଦି ଆମେ ଦେଖିବା Coriolis force is that the freely falling body. Okay, ଯଦି ଗୋଟେ body freely fall କରୁଛି, then it will deviate their true vertical path. Okay, true vertical path ଯଦି ଗୋଟେ body freely fall କରୁଛି ତାହେଲେ actual path ରୁ deviate ହେବ, and this deviation will be always towards east in either of the hemisphere. जे कौनसी गोलार्धरे भी पृथ्वीर से बॉडीटा फ्री फॉल करूथाओ, the deviation will act along the east direction, and in such a case the vertical fall means a velocity along vertical direction, and due to the horizontal component of Earth's angular velocity, Coriolis force starts to act in the horizontal direction, and it will deviate the freely falling particle from the actual true vertical direction. For example, if we consider a cyclone formation, we know that cyclone create way whenever the winds from high pressure goes towards the low pressure area. Okay, so in case of northern hemisphere, the winds blowing in towards a low pressure area will give rise to a cyclonic motion in the counterclockwise or anti-clockwise sense as viewed from above the surface of earth. Okay, याको यदि आमे फिगर रे देखिबा ताले देखो this one. Okay, so एठी winds जोटा बही के आसुची, okay, এই হিসাবে cyclonic formation यार देखेइबो in the counter or anti-clockwise direction. Okay, that is in the direction like this. Okay, right? अच्छा, similarly जदि गोटे आमे projectile fire करिबा horizontally at the equator, then the Coriolis force will tend to deflect it right to its direction of travel. Okay, that means देखो एठी आमे अर्थ रो सपोज एटा फिगर टे कला ओमेगा बा एंगुलर वेलोसिटी रो एटा हेगला वर्टिकल कंपोनेंट, एटा हेगला हॉरिजॉन्टल कंपोनेंट. हियर लैम्बडा इज द latitude angle. Remember this I have taken from another book. Okay, previous जो ऊपर हमें देखुतला that was the latitude angle phi. Here in this book the latitude angle is lambda. Okay, so जेमती कहली projectile suppose fire कला ताले accordingly यार direction v cross omega एई पटे पडुची, किंतु जदि Coriolis force when it acts on this projectile, then it will deflect it to the right of its direction of travel. Okay, so देखो এই হিসাবে deflection আসিলা. Okay, so if we assume the time of flight to be equal to suppose 100 seconds, okay, 100 seconds equal time of flight, then the angular deflection को हमें calculate करी परिबा by using this formula. It is found out to be around 0.4 degree. Okay, similarly free fall of a body yaku consider kariki on the earth surface, we can also solve some of the problems which are given in this book. You can read it. Next, moving further, ଯେମିତି କହୁଥିଲି ଏଇ ବହିରେ ଆଉ ଟିକେ ଇଲାବୋରେଟ୍ କରିଛି କିଛିଟା terrestrial and meteorological manifestations of Coriolis force. Okay, so Coriolis force ଆମେ already ଜାଣିଲା यार valueଟା ହେଲା mathematical value ହେଲା minus 2m omega cross v. This is an apparent velocity dependent force because velocity एठी अछि. Okay, which is arising from the earth rotation. Not only earth rotation, जे कौनसी rotating frame हमें consider करि परिबा. So खास कर यदि हमें एग्जांपल लेबा earth rotation because earth is a rotating body, then suppose we consider a particle which is moving uniformly across the diameter of a flat rotating disk. Okay, as you can see in the figure here, the disk is rotating with an angular velocity that is omega, and as you can see the particle is moving uniformly along the diameter. This is what observed by an inertial observer. But however, to an observer on the rotating disk, disk उपरे थिबा गोटे ऑब्जर्वर को केमती देखा जिवो एटा ताकू सेकंड फिगर. Here you can see the particle for this second observer which is on the disk, the particle is found out to be moving along a curve path. Okay, ये बड़िया curve path रे गला बड़िया ताकू देखा जिवो. Okay, so this type of motion obviously arising due to the Coriolis force which is acting on the particle and acting at right angles. Okay, perpendicular रहिबो to its velocity. Okay, एटा right आड़ को याकू move करूची. Okay, similarly आ गोटे example आमे नै परिबा the river flow on the surface of the earth. Okay, here suppose we consider a river flow which is along suppose x direction. Okay, x direction ए पटे आसिला. Similarly एठी z आउ y direction भी अछि. Okay, आउ एठी surface जो अछि earth रो एटा this one, this is our surface of earth, and let us say that earth is revolving or rotating with an angular velocity that is omega. Okay, so Coriolis force will act across the river that is flowing, and it will tend to change the direction of flow in the direction of this force. Okay, so एटी देखो x axis डायरेक्शन रे रिवर टा फ्लो करूची, किंतु एटी जदि हमें नहीं गला angle phi. Okay, angle phi which the x axis is making with respect to the geographical north. Okay, geographical north सहित x axis angle phi create कला ताले angular velocity of earth याको हमें ए हिसाब रे लिखि परिबा. एटी velocity of flow of river को हमें नहीं गला v equal to v I cap because एटी river टा x direction रे flow करूची ताले एटी Coriolis acceleration हमें बाहर करि परिबा. एटी m को हमें काटी नीचू. ओके, Coriolis force रो सो Coriolis acceleration हेगला 2v cross omega reach this much. ओके, सो एटी लैम्बडा हेगला nothing but the angle of latitude. Okay, now you can see from this the component across the river flow to the right will be how much? 2v omega sine lambda, which is independent of the angle phi. That is, this component does not depend upon the direction of river flow, so it depends upon the latitude of the place, that is lambda. Okay, so the river deviates and it deviates to the right. Okay, right direction the river flow have in the northern hemisphere. Similarly in the southern hemisphere the deviation will be towards left. So यदि तमे भारत मानचित्र को भी देखिबो, then also you can find out that maximum number of rivers, they are deflected along the left direction and goes towards the Bay of Bengal, right? अच्छा, next example है formation of cyclones. Already हमें यहाँ पर discussion कर सारिछु. You can see in the figure, if there is no Coriolis force, then the wind flow will be along this direction. But however, due to the presence of Coriolis force, এটা देखो right आड़े deflect ହେଲା ଆଉ ଏଇ deflection further cyclonic formation କରୁଛି, okay, anti clockwise direction ରେ, okay. আচ্ছা, এটা হচ্ছে আমি discussion করଛୁ in the northern hemisphere, okay. আচ্ছা, further next example ହେଲା the trade winds and tropical winds. This is also one type of example where the wind flows from the high to low pressure area, okay. So এই হিসাବରେ এটা ବି ମଧ୍ୟ you can see winds ର flow ଏଠି ଦେଖାଉଛି again in the anti-clockwise direction, just like that of your cyclone formation, okay. So these are some of the examples of Coriolis force. So this is all about the non-inertial rotating frames and Coriolis force.
Thank you.